Alright, ladies and gentlemen, when we move on here to section 5.3, we're being asked to evaluate log functions. And there's a couple ways to do this, but I always like to teach my students how to do it by thinking, not just punching into a calculator. Log base 8 of 64 is equal to what? Okay, here's what you're really being asked. Let's go off to the side. 8 raised to what power would give me 64? 8 to what power would give me 64? Well, that's a pretty easy one. The answer would be 2. So the log base 8 of 64 is 2. The answer that comes out of a log function is representative. It's a number, but it represents the exponent that the base needs to be raised to produce the input. Okay, one more time. This number is the exponent that this base would need to be raised to generate the input of the log function. Okay, let's come over here. Log base 12 of 1 equals what? Here's what you're asking yourself. 12 to what power would give me 1? And hopefully you remember laws of exponents. 12 to the 0 power would equal 1. So the log base 12 of 1 is equal to 0. Okay? Come over here. When you see log, you automatically know that that's the common log function, and common log is always base 10. So when the base is missing and you see log, you put 10. Okay, we don't know what this is. We're looking for it. So what we're asking ourselves here is 10 to what power would give me 0.01? Well, let's think about this a little more. 10 to what power? 0.01 is really 1 over 100. Okay? And what you need to remember back from whatever course you're coming to me from, 10 to a power giving me a fractional answer, this power would have to be a negative power, because it's actually taking this and taking the reciprocal. So 10 to what power would give you 1 over 100? Well, 10 to the second power would give you 100. 10 to the negative second power would give you 1 over 100. Okay? That's because 10 to the negative second power equals 1 over 10 squared, which is 1 over 100. Alright, so the answer is negative 2. The answer that comes out of a log function is the exponent of the base that gave me the original input. Negative 2. Alright, and let's look over here. 27, log base 27 of 3 equals what? 27 to what power equals 3? Well, let me do it a little bit more formally. 27 to the x power equals 3, okay? And x is what we're looking for. I'm going to call this x. There's a cool way to do this. Some people can see it by looking. The correct answer is 1/3. Because if you raise something to the 1/3 power, you're actually taking the cube root of it, and the cube root of 27 is 3. 27 to the 1/3 power is 3. 1/3 would be the answer. But a lot of people can't see that, so I show them some work. 27 to what power is 3? We're going to get a common base here. 27 can be written as 3 cubed, and of course the x is there. 3 can be written as 3 to the first. Alright, 3 to the 3 to the x would become 3 to the 3x power, and that's equal to 3 to the first. And basically here, the only way these two expressions could be equal, since they both have base 3, is for the powers to be equal. So that means 3x is equal to 1 when I divide by 3. X is 1/3. So whether you just see it right off the bat or whether you have to do a little bit more work to see it, the correct answer is 1/3. All right.